In the previous video, we took a look at how we're going to utilize graphs to be able to construct and characterize some of our quantitative data. So now we're going to analyze and we're going to see what do the graphs really mean. And there's three different ways to kind of characterize each of the different types of graphs, and we're going to focus on the histogram mainly. So sometimes we're taking a look at how many distinct peaks there are in a graph. And we call that the shape of the graph. So there could be one or two or three or sometimes even more than three. So we're going to come up with terms that are going to characterize that. If we want to look at where the majority of the data lies, that's called the center of the graph. And then we have this thing called the spread of the graph that describes if there's any gaps in the data. So let's start with the shape, and there's some terms that we can use. If there's only one distinct peak, we call that a unimodal graph. So unimodal means that there's one distinct peak. Bimodal means there's two distinct peaks. If there's more than two distinct peaks, that's called multimodal. And then if there's no peaks, in other words, we just basically have like a flat graph, that's called a uniform graph. All right. How do we describe the center of a graph? Well, the center of the graph is said to be skewed left, and I know it's backwards, if most of the data occurs on the right. All right, so if we kind of have like a tail that's going on the left side, that means more of the data is on the right. We call that skewed left. And in a case, we say skewed right if most of the data occurs on the left. And then if most of the graph most of the data occurs in the middle of the graph, we're going to call that normal. Sometimes we kind of say it's symmetric, but normal might be a little bit better. And then finally, there's only one way that for right now that we can characterize the spread of a graph. Now the spread of the graph, we're looking for these things called outliers. Okay? Notice they are not outliners. Okay, so they're called outliers. And if there's an outlier present, that basically states that there's going to be a significant gap somewhere between the data. All right, and we're looking for those. Now later in the course, we're going to interpret what those really mean, and we're going to define outliers numerically. But for right now, we're kind of doing the eye test of these histograms. And so as an easy exercise, all we're going to do is we're just going to describe the shape, the center, and the spread of each of the following histograms. All right, so we take a look at this one, and we notice that there's only one distinct peak. It's right in the middle there. All right, so we'd be very inclined to say that this is a unimodal graph. The center, most of the data looks like it's in the middle. All right, so if we're looking at the majority of the data, we could just eyeball it and say, well, that's where the majority of the data is. So since it's in the middle of the graph, we're going to call this a normal graph. And since the spread doesn't look like there's any gaps in the data, so there's no holes that are going on in the graph, it's just one solid blob of blue, we're going to say that this is going to have no outliers present. A second example. So we have this type of graph. All right. Now notice that there's two distinct peaks. There's one here that's a peak and one here that's a peak. The rest of them, they kind of dip down, so we can't necessarily say that they're peaks. All right. So this one's going to be a bimodal graph. It looks like that more of the data is on the left side of the graph as opposed to the right side. So since there's more data on the left, remember it's backwards, we're going to say that this graph is skewed. And skewed, since most of the data is on the left, to the right. And once again, there are no outliers. And in the last example, I'll show you that there is how to identify an outlier. All right, so hopefully that helps you to understand that. And then finally, we take a look at this last graph. The large majority of the graph is flat. All right, so if I could draw a line, and I'm going to, if I could draw a line like right about here, there's not much space that goes on either above or below. All right, so what we say about that is we say that this is basically going to be a uniform graph because there's no peaks. The center of the graph, very difficult for us to ascertain from this. All right, if I was to say anything, there's a little bit more data on the left and the right, so we could say slightly skewed to the right. All right, since more data is on the left, not lightly, but slightly, excuse me. And then finally, we do see that there's an outlier. All right, so we can clearly see that there's an observation, that there's a gap between the majority of the data and that observation. And so notice that it's between 700 and 800 on the graph. And so what we're going to say is that there's an outlier in the class 700 to 800. Okay, so we're going to identify specifically where that outlier is. Okay. So hopefully that gives you a good overview as to how to characterize the histograms, and more importantly, how to describe in words what these different quantitative sorts of graphs might look like. For our class, I'm only going to ask you to describe the shape, center, and spread of the histograms. All right, so try to be cognizant of that, just because the histogram is probably our go-to graph. It probably gives us the best description of quantitative data than any other graph. All right, not that the other graphs are useless, but just that the histogram is a little bit more useful than the others. In the next video, we're basically going to do a summary of everything that we've done so far, and we're going to apply it to a case and kind of get an idea of when we're going to use this sort of stuff in real life.